let's have a little look at this transition test then. So I'm prepped and ready to go here. I've got my periodic table, there it is. I've got my calculator, I have my coffee, and of course I have a biscuit because you need sustenance for these things. Right, okay, first up, energy levels are split into subshells. What is the correct name? Right, well I can tell you that 95% of people knew this, and of course it is S, P and D. Right, so you've just got to learn this essentially. So the S block is what we are now going to refer to as groups 1 and 2. The P block is what we are going to refer to as groups 3 to 8 or 0. And then the D block is what would have been this bit in the middle, which we refer to as transition metals. Right, so that was question 1, was SPD. Okay, question number 2. I know these, well, it says question number 3 actually, because obviously question number 1 was what's your name. Which one of the following could be classified as an S block element? So this obviously requires you to actually get it right the first one. So if you knew it was SPD, all you have to do is look to see which on the multi-choice list were in the S block here. And the answer, of course, was barium down here, Ba. And I can tell you that 92% of people got that right, which is lovely. Right, next one. Number 4. What is the following definition of? The energy needed to remove 1 mole of electrons from 1 mole of gaseous atoms. Okay, now this is just something you're going to have to learn. It actually crops up a lot in A-level, this definition. In terms of, you might have to write it, or sometimes you have to actually write an equation. So if we were talking about, I don't know, sodium, the energy needed to remove 1 mole of electrons from 1 mole of gaseous atoms, you would represent like this. And there we go. So that is what is known as the first ionization energy. So the first ionization energy. Again, it's just something you've got to learn, and it would appear that 92% of people got that right, so that's pretty nice. Right, okay, number 5. The oxidation state of argon. Right, this idea of oxidation states is really about being able to look at electron movement when, if you like, it's not obvious. So oxidation states are basically the same as the charge on an ion. So in your little thing, it was telling you that group 1 is +1, group 2 is +2, group 3 is +3. And then, obviously, group 4 doesn't form ions generally. Group 5, -3, 6, -2, 7, -1. However, right, the oxidation state on a compound will add up to 0, so you can then use that to work things out. Or an oxidation state of a compound ion will add up to the charge on that ion. Now, argon itself is an element, and one of the little rules that you had to look at was all elements, doesn't matter what they are, any element, doesn't matter what the formula either, right, they will always have an oxidation state of 0. So what I mean by that is, even if you had something like Br2, it would still have an oxidation state of 0. And I can tell you that 97% of people got that, so I should probably stop waffling about that. Right, next one. Strongest type of intermolecular force. You've just got to learn these. The intermolecular forces are something called van der Waals, dipole interactions, and the strongest type, which is something called a hydrogen bond. And all of this stuff we're going to go into in way more detail next year and have a look at how these things form. So hydrogen bonding was, again, a 95%er, so this is all pretty strong stuff. Correct formula of calcium hydroxide. Right, okay, so this was all about you realising that calcium was in group 2. So calcium forms a 2+ ion. Hydroxide, you are supposed to learn from GCSE, is an ion with a -1 charge. So therefore, you're going to need 2 of these for 1 of these, meaning that the formula will be CaOH in brackets 2. So only need 2 hydroxides for every 1 calcium. That one was, again, 89%, so pretty strong. Right, next, number 8, which is not a property of an ionic compound. Okay, so on this one, we had soluble in water, brittle, high melting point, conducts when solid, all right, and those were your options. Right, so conducts electricity when solid was the correct answer for that one. Right, ionic compounds, remember, are like this. Here's your ionic compounds made of positive and negative ions, strongly attracted together. So when it is a solid, it will not conduct. Right, you have to melt it or dissolve these to allow the ions to move. All right, so that was that one. What was it? Conducts electricity when solid. There was it. Conducts electricity. I can't even spell electricity when solid. So that is not a property of an ionic compound. Right, my stats on that one have gone a bit funny because I've just realised that I don't know why the auto marking's gone weird on that one, so I'll have to check that. You might all get another point, we'll see. Okay, so number 9, how many lone pairs of electrons does methane have? Right, a lone pair is a pair of electrons on the outer shell of an atom that are not involved in bonding. So basically you had to draw some methane, so you look on a periodic table and you can find carbon is in group 4. This is a very, very small drawing. I don't know why I've drawn it so small. Let's do that again. So here's some carbon, 1, 2, 3, 4, because it's in group 4, and then that means, of course, you need 1 hydrogen, 2 hydrogens, 3 hydrogens, 4 hydrogens, and all of those electrons are used in bonding, so there are no lone pairs. Okay, so the answer was 0. Get rid of that. Right, that one, did that go well? It went, yeah, 79%, not too bad at all. Okay, number 10. How many delocalized electrons per atom would there be in a block of strontium? Right, strontium is probably something you've never heard of. So you had to look at a periodic table. Right, where's strontium? It's in here somewhere. There he is, strontium. Right, strontium's here. So he's in group 2. So he's in group number 2. That means it'll have 2 electrons on the outside, therefore there would be 2 per atom delocalized. Right, and 89% of you sorted that out. Right, next one. What is being described? It increases because there are more electron shells, so the distance between the outer electron and the nucleus is greater. This means there is a weaker attraction between the incoming electron, that's important, and the nucleus. Right, so we're talking about something where electrons are incoming. Right, it increases as there are more electron shells. Okay, so more electron shells. Okay, distance between the outer electron, yeah, is greater, so that's got a greater distance. There's a nucleus, positive, electron, negative. This means there is a weaker attraction, there is indeed, between the incoming electron. Right, so incoming electrons, what needs to gain electrons? Well, this one you had options for, I can't actually see on my thing, what does it say? Why reactivity increases down group 1, why melting point decreases down group 1, why reactivity decreases down group 7, or why melting point decreases. Right, okay, so if we're looking at gaining or losing electrons, that's all about reactivity. And if it's about reactivity, if they're gaining electrons, that must be group 7. So this was looking at why reactivity decreases down group 7, because of course they all want to gain that electron, don't they? All right, because they've already got 7 already. There they are. So it wants to gain another electron, and therefore, if it's further away, there's a weaker attraction to that, so they will be less reactive. 21%, oh dear, that didn't go quite so well. All right, so yeah, it's, yeah, what did most people go for? Let's have a little look. Most people went for why reactivity increases down group 1. Ah, right, okay, so it's all about the fact there's an incoming electron here. Right, in group 1, reactivity increases, so there are more electron shells at distance group. Oh, I've just read the question again. This is a bad question, isn't it? All right, because that should say decreases. Oh no. Right, because there are more electron cells, blah, 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 blah. Right, okay, so this is a duff one. I'll get rid of it and recalculate your percentages because, yeah, all right, terrible question. Right, next one, move on. Number 12. Okay, a substance partially ionizes in aqueous solution and to produce H plus ions is a description of what? Right, okay, it partially ionizes H plus. You should be able to identify that. Means acid. Partially means weak. Okay, it is a weak acid. Okay, and how did that one go? That one went, well, 95%, correct, nice. Yeah, if I actually write the question correctly, you get it right, would you believe it? Okay, so next one, right, suddenly it all got a bit tricky. Okay, so ethanol can be made from glucose by fermentation, and then we've got some kind of yucky old maths. Right, a couple of things here. First of all, hopefully you recognise that this here is glucose, and you recognise that this here is ethanol. Well, even if you don't recognise them, you should be able to work them out. Right, so this one, what's the stats first of all? The stats were 34%, yeah. And I did actually get this question right, so yeah, that's not great. So this is all about moles equals mass over a relative mass, or what mass is Mr. Mole, depending on how you've been trained up. Mass equals Mr. Mole. Right, so that's the first thing. And then, of course, you've got to do a yield. So it's percentage yield equals actual over actual mass over theoretical mass times 100. Okay, this type of question is very common, I'm afraid. So we need to make sure they're okay with it. Right, so what have we actually got? We have got, let's do a quick rewrite down here. So we're talking about, you remember with these, there's only ever two things you need to worry about. So there's my ethanol, let's write that there. There's my glucose, let's write that there. Okay, so let's move it up a little bit. 268 grams of ethanol were made from 1.44 kilograms, oh nice, of glucose. Okay, so first up we've got different units, so that's just downright stupid. All right, so you'll remember this mass should really be in grams. No, it's not about it should be in grams. All right, so the first thing that seems sensible is to turn 1.44 into grams. So you can multiply that by 1,000, and of course that will give you a mass which is equal to 1440 grams. Right, we have been given a relative mass of these things. So glucose is, what's glucose? It is 180, yes. And the other one, ethanol, is 46. Right, now this here, it's tempting to get stuck into that number. That number you are not going to need until you're doing this bit, because that's in an experiment. That's actually what they made. So we're going to work out the theoretical mass, and then we have to do this bit at the end. Right, so moles. What's the moles? Well, it's going to be, what is the moles? It's going to be 1440 divided by 180, because moles is mass over relative mass, to give 8. Lovely. Okay, now if I look at my equation, there's all kinds of horrible here, because look, oh no, one of those makes 2 of those, so I have to times that by 2, which I think I can probably do in my head. There we go. So we get 60 moles of ethanol. Then to get our mass of ethanol that should have been made, it's going to be mass is Mr. Mole. So 16 times 46 is going to give you 736. So that is your theoretical mass. So therefore the yield is going to be whatever they said they made, 268 divided by 736 times 100. And if you do that, out pops the magical answer, which is, well, let's actually do it rather than just look at the answers. So 268 divided by 736 equals times 100 equals 36.4. And then you hope that that is one of the answers. And luckily, it is. So that's how you do that one. The answer was 36%. Right, that one was a lot trickier than the previous. So let's move on and see what happens now. Oh, right, a little page turn for me, that's annoying. So let's fold that, we don't want to see that again, do we? Okay, so what have we got? Gas cylinder contains 5 grams of propane, kilograms of propane, could be important. How many propane molecules are there? Okay, do I get any more information? Yes, I do. The Avogadro constant is that number. Okay, so I had 5 kgs of propane, and I've got that. They want to know how many molecules. Okay, so basically what they are testing here is, do you know what that number means? Now there's a little bit of a clue there if you can't remember. So that is the number of particles that are equal to 1 mole. So that is 1 mole of a thing. So if I can work out how many moles of propane I've got, all I have to do to work out how many molecules there are is times it by that number. So once again, you have to convert it to grams. So it's going to be 5,000 grams of propane. Then they're expecting you to know the formula of propane. Oh no. Prop, so meth, eth, prop, bute. Prop is C3. Double it, add 2, H8. Right, so therefore the MR of propane, which is obviously what you've got to divide that by, because it is moles equals mass over MR. So it's 5,000 divided by, what did I just say that was? 12 times 3, because the relative mass of carbon is 12, which I think I probably could do in my head, plus, well, the relative mass of hydrogen is 1, so just plus 8, so 8 times 1 gives 44. So you've got to do 5,000 divided by 44. 5,000 divided by 44 equals 113.63. 113.63 moles. Right, and if they want to know how many molecules, you multiply by that number. 113.63 times avocado, or Avogadro, times 6.022 times 10 to the 23, and gives a massive number. No surprises there. You want to expect it to be a large number. So 6.84 times 10 to the 25. Is that on the one thing? Let's hope it is. The answer was C. That's unhelpful because I can't see what C is. Let's hope that's right. That's annoying. Okay, well, I'm assuming it is, and that my math is good. Right, okay. Next one. Right, we're back into this kind of thing now. So a little bit of learn town. So just got to read these carefully. Which statement is not correct? They do love a not correct, right? These ones here, this one, these last 3 are actually taken from AS papers, whereas the previous ones are ones that I made up. That is an annoying Teams call, which is not for me, you'll be pleased to hear. So I'm just going to quickly move that to the other room. Okay, so this one is about intermolecular forces, and you've got to look at the one that is not correct. This is really common, like I said before, in A-level. So, intermolecular forces exist between all simple molecules. That is very much true. Right? Hydrogen bonding exists between HBr molecules. Right. Okay, hydrogen bonding only occurs when you have nitrogen, oxygen, or fluorine. Okay, so it has to be technically it is a highly electronegative atom, which is one of those 3, which is attached to hydrogen and has a lone pair of electrons. Right, so HBr is clearly not one of those, so that is not true. With these, you just got to be confident sometimes and just go for the one that's obviously wrong, but there are other ones as well. Hydrogen bonding is the strongest intermolecular force. It certainly is in liquid ethanol, because ethanol contains oxygen attached to hydrogen with a lone pair. Hydrogen bonds occur between CO and NH. They certainly do, because you've got hydrogen attached to nitrogen, which is one of those ones, so you get hydrogen bonds. Right, next one. So yes, the answer was C. And did that go well or badly? Don't know. Let's have a look at my stats. That says that it went 61%. Not too bad. Oh, calculating energy change. Right. Oh, enthalpy. That might have confused you because it said enthalpy. Enthalpy just means energy change at constant pressure, so it's the same kind of stuff. For the dissociation of mole, I think I should say 1 mole, but there's obviously only one, of propan 1-ol. Well, what is that? Well, that's this. Dissociation means breaking, so basically you've got to calculate the change for when you basically break that. So it's just the energy required to break all those bonds. Then it gives you some stats, and that's that. So what you have to do here is work out what propan-ol or propan 1-ol looks like. And as soon as you've done that, then actually it's pretty easy. So there's your propan 1-ol, and then you've just got to work out how much it takes to break all these bonds. So for this one, it's going to be, what do we got? CH is first. 1, 2, 3, 4, 5, 6, 7. So it's 7 times 412. Plus whatever it is next, CC, there are 1, 2 of those. 2 times 3, 4, 8. Let's do some brackets around those things. 2 times 3, 4, 8. What else are we doing? Next one, CO, there's 1 of those. 360 plus 360. And there is 1OH plus 463. Do that and out pops the magical number of 4403 kilojoules, which 47% of people got that right. Well, there you go. Okay, I'm not quite sure why. Probably just because you didn't quite have the structure of propan 1-ol correct. I think if you draw that thing out, then it's pretty straightforward. Right, next one. This one. Haha, cheeky. Okay, so we've got a volume of gas formed over time between magnesium and acid. So obviously that gas is hydrogen. Right, so that's hydrogen gas. Which one represents the volume of hydrogen formed at the same temperature and pressure when the concentration is halved? Okay, now, obviously, if you halve the concentration, they're telling you these things stay the same because, of course, they affect rate, don't they? All right, so concentration's halved, you're going to be halving the rate because there are half as many particles in a given volume. Okay, so I can't even see line X here. This is really annoying. Hang on. So it was, I can't remember what it looked like. Well, all I can tell you here is that is the fastest rate because it's going out quickly. That's fast. This one here is that looks like it's half. That's half. All right. And so you basically get it down to A or B because they're the ones where the original amount is half. Let's do a quick sketch of the original one because I haven't got it on mine. The original one was like this. Kind of like that, I think, ish. All right. That's supposed to be flat. So it's tempting to go here because it's obviously got a rate that's halved, and if everything else is the same, then surely it finishes at the same. But. Right, if all they've done is half the concentration, then that means that there are half as many particles of acid. So it says here the magnesium is in excess, so therefore the acid is the limiting factor. So if there's half as much acid, the total volume of gas is going to be halved as well. Right, so it should be half as much, and it should be half as steep. So relatively, it should look something like that. That's a really bad sketch. Anyway, the answer was A for that reason. I'm going to guess a lot of people got done by that. No, maybe not. 58. Okay. Where are we now? 17, 18. Here we go. Oh, it's this one. Okay. So this is the old thiosulfate cross. You might remember it from GCSE fun times. So we've got a little bit here. What's going on? They're looking at the cross. Blah, blah, blah. What's likely to decrease the accuracy, right? Accuracy is about how close you are to the real value. What I mean by that is there will be a real amount, a definite amount of time it takes for this thing to go cloudy, and you can't see through it. Which one of those is going to decrease that? Okay. If you have a look at each of these individually then, first up, rinsing the flask with acid before each new experiment. Okay, if you rinse your flask with acid, there is going to be more acid in that flask than you think you are putting in, right? You're trying to put in a set amount or volume of acid. So if there's a little bit more in there, then the reaction is going to take a little bit less time than it should have done. So straight off the bat, that is the right answer, okay? However, let's just quickly look at the other ones. Stirring the solution, well, that isn't going to decrease the accuracy because, of course, that makes sure the chemicals are mixed. That's a good thing to do. same piece of paper, well, that has no effect on what's going on inside the flask whatsoever. Different measuring cylinders to measure the volumes of acid and sodium thiosulfate. That's actually a sensible plan because the acid and the thiosulfate would react if you use the same measuring cylinder. So the answer was A. And that one was a 50%er. All right. 19. Which of the following do two H plus ions and one electron have to be added to the left-hand side to balance the equation? Right, so this is a counting activity here. So when you balance half equations, you might remember that you have to have the same number of atoms and the same charge. So first of all, you can discount A because what is it saying? It's saying you're adding two hydrogen ions. Let's just make sure we get a head around what this is. Two hydrogen ions and one electron to the left-hand side. So that is a total of +1 to the left-hand side. So first one, you're going to discount. Why? Well, because they've got the same charge both sides, so that will make it a mess. This one to the left side. Well, if I put +1 there, it makes it up to 3, so that could be that one. This one here, that's a -1, so that could be that one because there's 0 that side. Down here, well, in that one because that's got no charge each side either. So it's B or C. Then it's just a case of count the hydrogens. Well, 2 here, none here, 1 there, none there. Well, I've got 2 of them. So if I'm putting 2 on this side, plus an electron, it's got to be B. All right, 53% of you got that one nailed. Right, which one contains an element with an oxidation state of +4? Okay, so this here is a bit small to see. So we've got NO2 with a plus on it. To do oxidation states, you basically got to learn your basic ones, then work it out. So each oxygen is -2. If there's 2 of them, it's -4. Right, the whole thing has to add up to +1 because it's got to add up to the charge on the ion. So therefore, nitrogen must be +5. Okay, so it's not that one. Next one down here, ClO3 minus. Okay, this particular one. Okay, now this is one of the sneaky ones actually because it's got chlorine and oxygen in it. And you've got to know which takes priority. Now, chlorine is normally -1, sorry, but with oxygen it doesn't take priority. Oxygen takes priority. So you've got -2 there, -6. It's got to equal -1. So that's again +5, so it's not that one. What we got? Sulfuric acid. Well, no, it's a type of. It's got the 3 rather than the 4. That one, you got -2 there, -6 because there's 3 of them, +1. 2 of them makes +2. So therefore, it's got to equal 0 overall. So the sulfur must be +4. There you go. Right. So C was your answer, and that was a 34%er. We're going to go over these oxidation state rules again, don't worry about it. Okay, which was the next one? 22. Inorganic time, right, okay. So, which element has the highest first ionization energy? Right, so remember this is the energy required to remove an electron from a gaseous atom. So basically you're looking at the one where the electron is closest to the nucleus. All right. So aluminium, phosphorus, silicon, oxygen. So the first thing you can do is find them. Aluminium, phosphorus, silicon, and oxygen. Right, okay. Now you will notice, I hope, that oxygen, okay, is in a different period to the other ones. So if oxygen is in a different period to the other ones, then that is going to be significant. So all of these, they're outer electrons. So aluminium, silicon, phosphorus are in the third shell, so third main shell, and oxygen, its outer electron, is in the second main shell. Therefore, it's going to be significantly closer to any of those 3. Therefore, that will have the highest first ionization energy because it'll be harder to remove. Right, so the answer was oxygen, which was D. And 26% got that right. Oh dear. Right, next one. Which elements are shown in increasing order of the stated property? Right, so first of all, phosphorus, sulfur, chlorine. Phosphorus, sulfur, and chlorine. Phosphorus, sulfur, chlorine. You need to know that atomic radius decreases across a period. You might think that it increases, but it decreases. We'll talk about why next year. Right, it decreases across a period. So it's asking for an increasing, so it's not that one. First, IE, sodium, magnesium, aluminium. Right, sodium, magnesium, aluminium. In general, first ionization energy increases across a period. However, all right, for this one, there is a slight little nick. Don't even know if this was in the thing, actually. I hope it was, otherwise this is a bit of a stitch up. So it increased to magnesium, then there's a little drop to aluminium, right? So it's not that one. Electronegativity, right. Fluorine is the most electronegative and it decreases away from fluorine. So what are we looking at? Sulfur, phosphorus, silicon. Sulfur, phosphorus, silicon. Well, that's decreasing because they're getting further away. Right, so let's hope it's the last one. Argon, chlorine, sulfur. Right, argon, gas. Chlorine, gas, sulfur, solid. This is looking promising. That's diatomic, so therefore it's a larger molecule. That's going to have a higher boiling point than argon. So yes, it is indeed that one, D. All right, so that was your answer. 32% on that one. Yeah, these are getting nasty now, aren't they? Right, okay. The best technique to remove solid silver chloride that forms when aqueous solution of silver nitrate and sodium chloride react. Okay, so you've got here a precipitation reaction, all right, because you are making a solid from two solutions. So if you've got a precipitate and you want that, then that is going to require good old-fashioned filtration. All right, so I don't know why I'm drawing this, because you clearly all know this, but maybe you just haven't seen a conical flask for a while. All right, so there's your solution. That is your precipitate of silver chloride. Okay, hopefully that one went well. Did it? 76%. All right. Then organic chemistry. You're going to begin to know and love this if you don't love it already. Which of the following is not the correct name of the functional group shown? Right, I do appreciate it's a bit bodgy, this, because it's just using Word. But there was a thing in the book about different functional groups. That one is correct. You should remember it from GCSE. That one is also from GCSE. These two are new, although even if you haven't looked at those, which you should have done, but even if you haven't looked at those, you should actually recognise a C-double-bond-C as an alkene. So that is the one that is incorrect. 24 and 76% got that right. That's good. What do we call a family of organic compounds with the same general formula with similar properties that react in a similar way? Right, you'll notice there's no answers here because you just have to learn it, I'm afraid. It is that word which has too many O's in it. It's a homologous series. Just got to learn it. Right, we're nearly there. Are we nearly there? 25, yes. Okay, so 26. Which of the following would be the chemical test to confirm the presence of a C-double-bond-C? Again, I haven't put the multi-choice in because you really should just know this. Right, this is, of course, is the alkene, and what that will do is it will decolorize, that's what this says, honestly, bromine water, or if you like, it will change bromine water from orange to colourless. Right, remember it needs to be colourless is what you write, or decolorize. Haha, then the last little nasty bits, the extra maths content. So, this one, number 27. I've got a bit of scribble on here. The reason I've got scribble on is because these are things we're going to use. So, we have got here, student with a 10 centimetre cube sample of 1 times 10 to the minus 2 methanoic acid. So that is a concentration, you should recognise that unit, and that is a volume. And the student is asked to dilute this to a new concentration like that. Now, team maths can probably do a bit of shortcutting here because you can kind of just do this by ratios. But I'm going to show you the way using the equation that you should be familiar with, which is concentration equals moles over volume. Concentration is moles per decimeter cubed. Apologise about my terrible writing. And then let's just sort this out because this is not actually right. Okay, and then the volume has to be in decimeters cubed. So, concentration, 1 times 10 to the minus 2. Volume, 10 divided by 1,000. Okay, so you're going to do 1 times 10 to the minus 2, right, times 10 divided by 1,000. Oops, let's try and do that right. And that will give you a 1 times 10 to the minus 4 moles. Right, so that's the number of moles that we have at the start. Then we've got to dilute it to a new concentration. So that's this, 2 times 10 to the minus 4. So up here needs to be 1. So this is just the same equation. Concentration is moles, which we've worked out, divided by V, which we don't know. So to get V, you're going to pop V up there. That's coming down here. So you're doing 1 times 10 to the minus 4 divided by 2 times, why am I even doing this? Times 10 to the minus 4 equals clearly 0.5. Okay, 0.5 decimeters cubed. They want it in centimeters, so let's pop that in centimeters by multiplying by 1,000. Okay, so that will give us 500 centimeters cubed. And then, of course, it's tempting to write 500. But what water should be added? You got 10 centimeters cubed of this stuff already, right? Okay, so that 10 centimeters cubed, the total volume needs to be 500. So the amount that you add has got to be 490, which is like proper cheeky. Okay, so that was a tricky old question, I'm not going to lie. How did the stats go? The stats went, 21%, yuck. Right, let's look at the next one. 28. What is the number of atoms in that many moles of ammonia? Then it's very similar to the propane one, this. So, okay, this one then. First of all, if we have that many moles, it's going to be this many, times 10 to the 23. That many molecules of ammonia. That's your first step, probably. I mean, you can do this in a different order, but this will do. Times 6.02, 2 times 10 to the 23. So that's the number of molecules of ammonia. 2 times 10 to the 21. Okay, now, unfortunately it wants the number of atoms because they're a bunch of idiots. So each molecule of ammonia contains 4 atoms. So you've got to multiply that number by 4 and then pray to the gods of multiple choice that it's one of the answers. Yes, it is. All right, so the answer was D. 39% on that one. Yuck. However, last one turned up better. Right, okay, which one of these contains the greatest number of atoms? Right, so we need to, we don't need to know the Avogadro number, we just need to know the number of moles, because of course, to get the number of atoms, you just multiply them all by the same number. So, 127 milligrams, so 127 milligrams. To stick that into grams, we need to divide it by 1,000, and then multiply it by the relative mass of iodine. Iodine's relative mass is 127, but iodine, of course, is good old I2, so that's times 2. So let's chuck that in and see what happens. Times 1,000 divided by 2 times 27. Nope, let's try that again. 2 times 127, there we go. That will give me 500. Okay, right. Hang on a minute, that's not quite right, because that is not how you convert into grams, sorry. That should say times. Right, okay, so 127 milligrams, if I want it in grams. Oh, jeez, it's not, it's right, it was divide. Let's try that again. It was divide. 127, I'm having a meltdown. 127 milligrams. Milligrams, if I want it in grams, clearly the number of grams is going to be smaller. So divide by 1,000, answer 500. Have confidence in yourself, I was doing it right. Right, okay, next one. 1.54 times 10 to the minus 4 kilograms. Right, if I want that in grams, this time I am multiplying by 1,000. And then divided by the relative mass of phosphorus, which I believe is 31. So that looks like it's going to be a relatively small number. Let's just confirm. Times 10 to the minus 4. You probably appreciate, you probably don't need to do all of this stuff, but I'm just doing it all for fun, really. There we go. Oh, look at that. It's tiny. don't even need to write it down, so it's definitely not the winner. 9.7. Next one, what's the next one? Next one, CO2, right, okay, so 81, right, milligrams, get it right this time. Divide by 1,000. CO2 is 44 relative mass, so 81 divided by 1,000 equals, divided by 44 equals, another small number, it's not going to win, 184. So our final contender is ammonia, 1.7 times 10 to the minus 4, multiplied by 1,000, put it in grams. Relative mass of ammonia is 17. Let's chuck that in. 1.7 times 10 to the minus 4, nope, not plus, times 1,000 equals, divided by 17, 0.00588. Right, what's going on here? I've done some bad maths back at the beginning, haven't I? Quite clearly. All right, so let me just sort that out again. 127 milligrams, 127 divided by 1,000 is that number, divided by, have I got the maths right? Yeah, 7 times 2 is clearly not 500. I think the basic maths could have told me that. 5 times 10 to the minus 4. Right, telling me my winner is what I want, biggest, don't I? Yay! All right, ammonia, down the bottom. There he is. That's the largest number. That took way too long. Quite clearly, you could have done a little bit of this sort of business without doing what I did. But there we go. Hope that was an enjoyable experience for you. It wasn't for me. I'm going to eat a biscuit.